Hi, this is the third video about inverse functions, and in this video we're going to focus on inverse tan and give you some hints about the practice. We did in a previous video inverse sine and inverse cosine without a calculator by using our unit circle. So in this video, here's the example I'm going to be working on, which is inverse tan of negative square root of 3. And it's the same exact question, which is find the exact value. Whenever we see the word exact value, that should remind us that this has to be done without a calculator by using our unit circle. And you can see it here to the right. Inverse tan is a little bit harder than inverse sine and cosine just because with sine, we can directly see the y coordinate. With cosine, see the x coordinate. The tan is sine over cosine. In other words, it's y over x. So we have to think about what fraction has to give me the value that I want. So it's a little bit more of an analysis rather than looking at the coordinate and saying, oh, this is what I'm looking for. So it requires a little bit more work. Let's start with this. Whenever I see inverse tan or inverse sine or cosine, I want to think about it in words. Which angle has tan equal to negative square root of 3? So tan of an angle, I don't know what this angle is. This is what I'm about to figure out, is equal to negative square root of 3. In other words, which angle has, in terms of our building blocks, sine and cosine, y over x equal to negative square root of 3. And whenever I work with inverse, I need to remember that I'm limited. I'm not allowed to work with the whole unit circle. There is a range of the inverse function. I look at tan, and the range is between negative pi over 2 and pi over 2, which covers the first and the fourth quadrant. There is a hint in the question that it's not going to be the first quadrant, and this is the hint. So when I work with this, it's first or fourth, but since tan is negative, so it cannot be in quadrant 1. So now I know for sure I'm gonna be looking at quadrant 4. And having the range as negative pi over 2 to pi over 2 gives me the hint that I'm working with negative radian. So I'm reading those angles when I need an angle. And again, we're in the fourth quadrant. So think about it. You would say there's one of those angles that cannot be the answer. And if you think about it for a quick minute, you can tell that this one can be crossed. The reason why is the coordinates are the same, whether positive or negative, we don't care, but that means the tan, in this case, cosine positive, sine negative. So the tan of this angle is going to be negative 1. The tan of negative pi over 4 equals negative 1. That's not what I'm looking for. I want the tan to be negative square root of 3. So how can I get a y over x equals a negative square root of 3? So I'm left with either, we said here it's undefined, the tan in the previous video, because it's y over x, negative 1 over 0. Right here, the tan is y over x, 0 over 1, which is 0. That's not the value I'm looking for. So I'm left with two options, either a negative pi over 6 or negative pi over 3. Y over x has to equal to negative square root of 3. So the top has to have a negative square root of 3 in it. I can double check. So what I'm going to do is I'm going to keep change flip. So I'm going to keep divided by half, keep change flip. 2 over 2 will cancel out, and I'm left with negative square root of 3. And those are the coordinates of negative pi over 3. If you try the other one, you are going to get 1 over negative square root of 3, which is not what we're looking for. And this is how we solve inverse tan. Quick hints about the practice problems. There's one question, which is question 9, that has inverse sine of -1 over square root of 2. This coordinate does not look familiar on the unit circle. I never have a 1 over square root of 2 or -1 over square root of 2. This is why I need to rationalize first in order to make it look familiar. So multiply top and bottom by square root of 2. One more last hint for those problems, you might see this notation, which is arc sine, and arc sine simply means inverse sine. Arc cosine, and this simply means inverse cosine. Always read the question thoroughly because sometimes it tells you give the answer in radian, so you have to make sure your calculator is set to radian. And sometimes it tells you give your answer in degree, so you want to make sure your calculator is set to degree. So now go ahead and take some moment to practice page 385, number 1 through 12, without a calculator, and 13 through 20 with calculator.